Supposing the masses are 6 kg, 10 kilograms and 4 kilograms. Now the three pulleys are massless and the rope is also massless. So the tension in the rope is the same everywhere. It's a single rope that goes from the 6 kg, goes over, comes under and goes over like that. And the central pulley, which is also massless, is free to move up and down. Now the question is, how do we write down the constraint equation? What is the constraint equation? And how do we find the accelerations of the three blocks? So I will teach you a simple trick on how to find the equations. First, we are going to assume down is positive. And let us assume that the 6 kg block moves down by an amount x1 and the 10 kg block moves down by an amount x2 and the 4 kg block moves down by an amount x3. Now all we are saying is that we have called these displacements x1, x2, x3 from some positions, it doesn't matter. Now all three will not move down. Clearly, at least one or two of these x's is going to turn out to be negative, which means that those blocks actually move upward. But all we are doing is we are defining the displacements positive downwards so that if they turn out to be negative, they are actually moving upwards. All right. Now, when this one moves down by x1, this part of the rope increases in length by x1. When the central block moves down by x2, this part of the rope increases by x2. This part of the rope increases in length by x2. So the increase in the length is 2x2. And then when the 4 kg block moves down, the last section of the rope, the rightmost section of the rope, increases in length by x3. So this is the total increase in the length of the rope, and of course that has to be 0 because the rope is inextensible. If you look at this equation, you can see straight away that all three cannot be positive. At least one or two of them will be negative, which means those blocks will actually be moving upwards. Now these x1, x2 and x3 are the displacements as a function of time, so we can differentiate them. We get the velocities v1 plus 2v2 plus v3 equal to 0. v1 is the velocity of the 6 kg block downward, v2 is the velocity of the 10 kg block downwards, v3 is the velocity of the 4 kg block downwards. Again, all three cannot have velocities moving downwards, so at least two of them or one of them will be upward. Let's differentiate again. We get acceleration of the first block plus twice the acceleration of the middle block plus the acceleration of the 4 kg block equal to 0. This is the constraint equation that relates the three blocks' accelerations. See how simple it is? I'll teach you this trick quickly again. You start by assuming that each one moves downward by x1, x2, x3. So the total increase in the length of the rope will be x1 plus 2x2 plus x3, and that has to be 0 because the rope is inextensible. Differentiate twice, you will get the corresponding equation a1 plus 2a2 plus a3 is 0. That's the constraint equation. Now to find the accelerations, we need to write down the forces. Let's write down the forces. So on the 6 kg block, there's a tension pointing upward and gravity 60 Newton pointing downwards. On the middle block and pulley, we have tension upwards because rope will only pull, you can't push with a rope, and there is a downward force of 100 newtons, which is the weight of the 10 kg block. And then on the 4 kg block, there's tension upward and a downward force of 40. Since each of them is assumed to accelerate downwards with a1, a2 and a3, let's write down the force equation for each one. For the 6 kg block, the net downward force is 60 minus t, because t is pointing upward, is equal to 6 times a1. For the 10 kg block, 100 minus 2t. Remember, on the middle block and the pulley, there are two tensions acting. So 2t is equal to 10A2. And the last 4 kg block, we have 40 minus t is equal to 4A3. So you see, we have A1, A2, A3 and T, 4 unknowns, and we have these 4 equations to solve for the 4 unknowns. And we will get the tension as well as the acceleration of each block. Let me show you how to do this very quickly, right? So from this equation, we have A1 is equal to divide by 6. So I get 10 minus T by 6. And from this equation, I get A2 is going to be equal to 10 minus 2T by 10. So that is T by 5. And from this equation, I'm going to get A3 is going to be 10 minus T by 4. So we take this A1, A2 and A3 and substitute them into the constraint equation. So let me do that. A1 is 10 minus T by 6 plus 2 times A2. A2 is 10 minus T by 5 plus A3, which is 10 minus T by 4, and the whole thing is equal to 0, and we solve this for tension. If we do that, we find the tension is equal to, I'll let you solve that. You should get 2400 by 49 newtons. Wonderful. We have the tension. Now we just need to substitute the tension into each of these equations and find the corresponding accelerations. As an example, I'll just do one of them. Let's find A3, the acceleration of the 4 kg block. A3 in yellow color. So A3 is going to be equal to 10 minus T by 4. T is 2400 by 49. When you divide by 4, I should get 600 by 49. So that is equal to 490 minus 600 by 49. And that is 10 and 100. 110 minus 110, because 600 is more than 490, divided by 49 meters per second squared. That is the acceleration of the 4 kg block. And since it turned out to be negative, it means that the 4 kg block is actually accelerating upwards. So in the similar manner, you can find A2 and A3. So I'll leave it here. See you in the next video.